Hello everybody, welcome into another lesson. Today we are going to find the greatest common factor of numbers and monomials. So how do we do that? Well, first let me write down what we're going to be doing exactly. That might help if we can know what we're going to be doing. So find the greatest common factor. We will find the greatest common factor. Alright. Let's say we have the numbers 12 and 8. We want to find the greatest common factor of the numbers 12 and 8. The greatest common factor of both of these numbers. Well, how do we do that? The way to do it is take the prime factorization of each number. So you have 12. Well, let's pick 3 and 4 for our factors. Of course, we know the 3 don't factor any further. That's a prime number, but 4 factors further into 2 and 2. We're done factoring 12 because we can't factor 2's any further. Now let's factor the 8. Well, 2 and 4 are going to be factors. 2 don't factor any further, but 4 factors further into 2 and 2. Okay, now we have factored 12 and 8 both completely. If you want to find the greatest common factor, what you need to do, circle what they both have in common. Both of them have 2 2's in common. So both 12 and 8 have 2 2's in common. They don't have a third 2 in common. They don't have a 3 in common. But you do see both have 2 2's in common. So the greatest common factor, the GCF, is going to be 2 times 2 for each. So that'd be 2 times 2, which we know 2 times 2 is 4. So the greatest common factor of 12 and 8 is going to be 4. Because you do 2 times 2, you get 4. And I do have more, and you're probably wondering, why do you want to find the greatest common factor? Well, when we go to factor expressions later, you're going to see that you're going to want to find the greatest common factor to do that. It's used in factoring algebraic expressions. Alright, what's the next one here? This one should be easy. We'll have 3 and 9. Well, 3 don't factor any further. That's done. We can't factor 3 any further. But we can factor 9 further. You'll have 3 and 3 as factors of 9. What do they both have in common? They both have 1 3 in common. And that's it. They both have a 3 in common. So your greatest common factor of 3 and 9 is just simply 3. Greatest common factor is 3. Okay. We have 24 and then 40. So we got 24 and 40. What is the greatest common factor of 24 and 40? Well, let's start factoring. You can do 3 and 8 as factors of 24. 3 can't factor any further, but 8 certainly can. You'll get 2 and 4. The 2 can't factor any further, but 4 certainly can into 2 and 2. Now we've factored 24 completely. Let's look at 40. You'll get, well, you know what? Let's do 5 and 8. It doesn't matter what factors I pick, but it seems like less to do if I do it this way. So 5 and 8 would factors of 40. We can't factor 5 any further. We could certainly factor 8 further into factors of 2 and 4. Well, 2 don't factor any further. 4 certainly does into 2 and 2. Now, what you want to do, circle what numbers do they have in common. Let's see. They each have 1, 2, 3 twos. 1, 2, 3 twos. So we got 3 twos in common for each one. 3 and 5 are not common to either of them. So your greatest common factor is going to be equal to 2 times 2 times 2, which we know is equal to 2 to the third power, which is equal to 8. So your greatest common factor of 24 and 40 is going to be 8. That's how you'd arrive at that. We have 3 common 2's in each one, so it's 2 times 2 times 2, which is 2 to the third, which equals 8. Alright. What can we do next? Alright, how about 30 and 35? So we got 30 and we have 35. Let's start with 30. 30, of course, you have 5 and 6. Those are factors of 30. Well, you can't factor 5 any further, but you can factor 6. You would get 2 and 3. Okay. Now, 35, you get 5 and 7. You can't factor either of those any further, so let's look for what both 30 and 35 have in common. It looks like the only thing they have in common is a 5. That's it. They only have a 5 in common. So the greatest common factor of 30 and 35 is going to be 5. That would be your answer. The greatest common factor would be 5. That's all the two of those numbers have in common, is 5. Alright, let's change it up a bit here. Let's say we do 3 numbers. We have 9, 15, and 24. So now we're doing it with 3 numbers, 9, 15, and 24. Well, 9 will factor into 3 and 3, and that's all that'll factor into is 3 and 3. We're done with 9. How about 15? 15 will factor into 3 and 5. Can't factor those any further. You're done with 15. 24. That'll factor into, we could do 3 and 8. 3 won't factor any further, but 8 certainly will. That'll factor into 2 and 4. The 2 don't factor any further, but the 4 certainly does into 2 and 2. Now, let's look for the numbers that all 3 have in common. They definitely all have a common 3. All 3 of them have a common 3. Do we have any other common numbers? No. So your greatest common factor for these 3 is going to be 3. So your greatest common factor of 9, 15, and 24 is 3. That's all they have in common. So that's how you would arrive at that result. Alright. Let's do one more with 3 numbers. We have 20, 28, and then we have 36. So we got 20, 28, and 36. Let's find the greatest common factor of those 3 numbers. Well, 20, that'll break down into 4 and 5. Can't factor the 5 any further, but we could sure factor the 2 further into 2 and 2. We've done and factored 20. Now how about 28? We got 4 and 7. 7 won't factor any further, but 4 will into 2 and 2. We've done and factored 28. We can't do that any further. Now how about 36? Well, let's do 6 and 6. Each of those will factor further into 2 and 3. Each of those factor further. 2 and 3 are the factors. Okay? we can't factor 36 any further. Now let's go through, start looking for what they have in common. They both seem to have two 2's in common. They definitely seem to have two 2's in common. They don't have a 5 or a 7 or 3's in common. So all they have in common, your greatest common factor, is going to be equal to 2 times 2. So it's 2 times 2 on each one, which would happen to mean that that's 2 squared, which would happen to mean it's 4. So the greatest common factor of 20, 28, and 36 would be 4. Okay, I think we've done enough with numbers. Let's do some monomials. Let's deal with some monomials here. Alright. So we have 18, and then we have 45 mn. So 18 and 45 mn. Well, let's find the greatest common factor of those two. Once again, we break it down by its prime factorization. So 18, you have 2 and 9. Those are factors. 2 don't break down any further, but 9 does into 3 and 3. We've done and factored 18. That's all we can do there. 45, you got 3 things being multiplied, so we can factor out 45, we can factor out m, we can factor out n. Well, we know right away we can't factor m or n any further, but we could sure factor 45. 45, that would be 5 and 9. 5 and 9 will factor into 45. We can't factor 5 any further, but we could sure factor 9. That would be 3 and 3. Now let's go through and start looking for what do they have in common. Immediately, 2 3's should jump out at you. Each of them have 2 3's in common. Is there anything else in common? They don't have a 2 in common, they don't have a 5 in common, or an m or an n in common. So your greatest common factor for each one is going to be 3 times 3, which is equal to 3 to the second power, which is equal to 9. So the greatest common factor of 18 and 45 mn is going to be 9. So this is why we spent so much time yesterday on prime factorization, because it's a very useful tool when you go to factor. Alright, we have 24t squared and we have 32. So we got 24t squared and 32. Well, once again, let's do the prime factorization of each number. You have 24 times t squared, so 24 and t squared are factors of 24t squared. Now, what's a factor of 24? Factors of 24 would be, we could do 3 and 8. 3 don't factor any further, but 8 does, into 2 and 4. 2 don't factor any further, but 4 does, into 2 and 2. We've completely factored the 24. Now t squared, that would just factor into t times t. We can't factor the t's any further. We're done there. We factored 24t squared completely. How about 32? Well, you can have 2 times 16. So 2 times 16 are factors of 32. 2 don't factor any further, but 16 does. 16 factors into 4 and 4. Each of those 4's factor into 2 and 2. So now we have factored 32 completely. Let's go ahead and start looking for common factors they have amongst each other. So we have, do they have 3 in common? No, they have no 3's in common. It looks like they at least have 3 2's in common. So they do have three 2's in common. Because this one has three 2's, this one has at least three 2's. Do they have a t in common? No. So your greatest common factor is going to be 2 times 2 times 2, which is equal to 2 to the third power, which equals 8. So your greatest common factor for 24t squared and 32 is 8. That's all you would get for that. All right. So we have 12x. So we're going to get the greatest common factor of 12x and then 40x squared. What is the greatest common factor of 12x and 40x squared? Well, let's start by factoring them out. Of course, of 12 and 12x, you have 12 and x. We can't factor x any further, but we can factor 12. 12, you could have 3 and 4. 3 don't factor any further. 4 does, though. 4 does into 2 and 2. Alright, we factored 12x all we can. Now let's go to 40x squared. Well, 40x squared, you could start with 40 and then x squared. Those are factors of 40x squared. Let's factor 40. 40, you get 5 and 8. 5 don't factor any further. 8 does, though, into 2 and 4. 2 don't factor any further. 4 does into 2 and 2. Alright, we've factored 40 completely. How about x squared? Well, x squared will just factor into x and x. We factored x squared completely, therefore we factored 40x squared completely. Okay, let's go through now, circle what do each of these have in common. They don't have a 3 in common. They definitely have at least two 2's in common, by judging by what we see here. They both have two 2's in common. They even have an x in common. They both have an x in common. So the greatest common factor is going to be equal to 2 times 2 times x, which would equal 4 times x, which would simply equal 4x. So the greatest common factor for this set of numbers, the set of monomials, is going to be 4x. That's exactly what you would get, is 4x. Alright. Make sure you could see all that. Yep. So yes, this is very important for when we go to factor expressions. Everything I'm teaching is building up upon itself into something else. Alright, let's say we have 4st and then we have 10s. 4st and 10s. We need to do the greatest common factor of both of those. So what we got to do is the prime factorization for each one. We have 4 times s times t. That splits 3 ways. You'll have 4 times s times t. We can't factor s and t any further. They're already as good as they're going to get, but we can factor the 4 further into 2 and 2. Okay, how about 10s? Well, we can factor that into 10 and s. We can't factor the s any further, but we can factor 10. 10 factors into 2 and 5. Well, we can't factor 2 or 5 any further, so we factor 10s completely. Now let's go through and look for what do they have in common. Immediately, we see that both of them have a 2 in common. They also both have an s in common. And that's it. That's all they have in common, are a 2 and an s. So your greatest common factor is going to be 2 times s, or just simply 2s. That would be your greatest common factor for these two monomials, would be 2s. All right. Let's do one more of this, then we're going to move on to factoring some expressions. We have 21x squared y and 63xy squared. So we got 21x squared y and 63xy squared. Well, let's start with taking the prime factorization of each monomial. Let's do 21 then times x squared times y. That'll break down into three parts. You'll have 21, then the x squared, then the y. We can factor 21 into 3 and 7, and that's about as good as that's going to get. X squared, that'll actually factor into x times x. The y factors no further. It's as good as it's going to get. So we factored 21x squared y completely. Now let's do 63xy squared. That would give you 63x, then y squared. So 63 will break down into 7 and 9, at which time 9 breaks down into 3 and 3. That's it for the 63 part. X won't break down any further, but y squared will break down into y and y. So we've completely factored 63xy squared. Now, like you would any other time, go through, look for what do they have in common. They definitely both have a 3 in common. They both have a 7 in common also. They even have an x in common. They even have a y in common. So we've gone through, looked for what do they have in common. They have a 3, a 7, an x, and a y in common. So your greatest common factor is going to be equal to 3 times 7 times x times y, which would equal 21xy. When you do the multiplication, you would get 21 times x times y, which would just be 21xy. So 21xy is your greatest common factor of these two monomials. This is very useful for when we go to factor expressions, which is what we're about to do. All right. Now we are going to factor the expression. So let's factor the expression. Let's start with the first one. We got 2x plus 8. We're going to factor 2x plus 8, okay? Like you would with monomials, you're going to factor each expression. Go over to the side, factor each expression here. Do the prime factorization of each one. Well, prime factorization of 2x, let's start with that. That'll break down into 2 times x. We've factored 2x completely. Now how about 8? We got 2 and 4. 2 can't factor any further, but 4 can factor into 2 and 2. Now, what do 2x and 8 have in common? They both have 1, 2 in common. And that's all they have in common. So, the greatest common factor for 2x and 8 is just going to be 2. Alright, now that we found our greatest common factor, what you need to do is come over here. We have the 2x plus 8. You'll write 2, then in parentheses, because you got 2 on the outside of the parentheses, 2 times what equals x? 2 times what equals 2x? X. If you multiply that 2 times x, you'll get 2x. So 2 times x equals 2x, plus 2 times what equals 8? 4. So 2 times x equals 2x. 2 times 4 equals 8. So therefore, we have factored the expression to be 2 times the quantity of x plus 4. And if you perform the distributive property, you'll get 2x plus 8. That's a way to check it if you want. Alright, that was a relatively simple one. Definitely need to clean my board, that's for sure. Here's one like it. We have 3r plus 12. So you got 3r plus 12. Well, let's go over to the side, do our prime factorizations. Let's factor each one. So 3 times r would break down into 3 and r. And we factored that completely already. There's nothing we can do further with 3r. 12, you have 3 and 4. 3 times 4. 3 factors no further, but 4 certainly does, into 2 and 2. Now just look for what do they both have in common. Well, they both have a 3 in common, that's for sure. They don't have an r or 2 in common, so it settles it that your greatest common factor is 3. Now that you've identified your greatest common factor for each term, you're going to take that greatest common factor outside of the parentheses. So 3 times what equals 3r? Well, r. 3 times r equals 3r. Plus 3 times what equals 12? 4. So if you did the distributive property, you would get 3r plus 12. It would factor back out. Because 3 times r equals 3r, 3 times 4 equals 12. So therefore, the factored version is 3 times the quantity of r plus 4. Alright. We have 8 plus 40a. 8 plus 40a. Well, like you would with any other, come over to the side, do your prime factorization of each term. Okay. We have factors of 8 would be 2 and 4. Well, you can't factor 2, but you can factor 4 into 2 and 2. That's all you can do for 8. You've already factored 8 completely. Now 40 and a. Well, you would just have 40 times a. Those would be your factors, 40 and a. Can't factor a any further, but you could factor 40 further. You would have 5 and 8. 5 don't factor any further, but 8 certainly does. 8 factors into 2 and 4. 2 don't factor any further, but 4 factors into 2 and 2. Now let's look for what do each of these expressions have in common. Immediately, all 3 2's. They both have 3 2's in common if we circle that. So they don't have anything else in common. They don't have a 5 or an a in common. So your greatest common factor is going to be equal to 2 times 2 times 2, which equals 2 to the third power, which therefore equals 8. Your greatest common factor is 8. So now you take that greatest common factor of 8, put it outside of the parentheses. 8 times what equals 8? Well, 1, because 8 times 1 is 8, plus 8 times what equals 40a? That'd be 5a, because 8 times 5a equals 40. So that is your factored expression, is 8 times the quantity of 1 plus 5a. Alright. Got 3 more, then we're done. We have 6 plus 3y. So 6 plus 3y. we have here, of course, again, two terms. Let's do the prime factorization of each one. 6 will break down into what? 2 and 3. Well, we sure can't factor 6 any further. That's all we can do with 6. 3y will factor into 3 and y. We can't factor 3y any further. That's it. They both have a common 3. So therefore, 3 is their greatest common factor. Greatest common factor is 3. So you take your greatest common factor of 3 over here, put it outside the parentheses. So 3 times what equals 6? 2. Plus 3 times what equals 3y? Just y. 3 times y equals 3y. So your factored expression is the quantity of, it's 3 times the quantity of 2 plus y. And you guys will get to a point where you'll be able to just factor without having to do the prime factorization of each factor. You'll be able to do it. Some of you probably already can, or most of you already can. So if you already know how to do this, I'm sorry, but I'm teaching it for people who don't know how to do it. But eventually, yes, you'll be able to look at it and say, oh, 3 is the greatest common factor, and then you can just, put that outside the parentheses and go from there. But today's goal is to show you where all that comes from. Because we got to remember, we're not in Algebra 1 yet, where it'll be more expected. We're only in Pre-Algebra, so... Alright, so we got 15f down to the last two. We got 15f plus 18. So we got 15f plus 18. Well, like you would anything else, find the prime factorization of both numbers. 15f, that'll break down into 15 and f. F won't factor any further, but 15 will, into 3 and 5. We factored 15f all we can. How about 18? 18, that would be 2 times 9. 2 don't factor further, but 9 will factor further into 3 and 3. Okay. Now, we factored 18 completely also. What do they both have in common? The only thing they both have in common is a 3. So the greatest common factor is going to be 3. So now you'll take your greatest common factor up here. You'll have 3 outside of the parentheses. So 3 times what equals 15f? That'd be 5f. Plus, then 3 times what equals 18? Well, that'd just be 6. So the quantity of 3 times the quantity of 5f rather, plus 6, that is your factored expression. Alright, I got one more here. Just one more for today. Good one. We have 14 plus 21c. So we have 14 plus 21c. We got to factor that. Well, like you would any others, factor each term. You have 14 and 21c. So factoring 14, you get 2 and 7. You can't factor it any further. You've already factored 14 as far as you can. Now 21 and 21c, that'd be 21 and c. You can't factor c any further, but you could sure factor 21 further. That would just be 3 and 7. Now what do both terms have in common? The only thing they seem to have in common is a 7. So the greatest common factor of each of these terms is 7. So now you're going to take your greatest common factor of 7, put that outside of the parentheses, so 7 times what equals 14? 2. Then we have plus 7 times what equals 21c? That'd be 3c. Remember, it's just kind of like 7 times what equals 21, then you just tack on the variable. So that'd be 3c. So your completely factored expression is 7 times the quantity of 2 plus 3c. And that's really all there is to it. This is basically just almost like a review of prime factorization, only we did it with 2 and even 3 numbers, and we did it with monomials, and then we use it to factor expressions. It's really not that difficult. The greatest common factor comes into play a lot in factoring. And it's also going to come into play in our next lesson, which is going to be simplifying algebraic fractions. We will simplify algebraic fractions next. So there won't be a lesson tomorrow because I have obligations going on tomorrow. Sometimes life gets in the way, but look for a lesson on Tuesday where we will talk about simplifying algebraic fractions. Hope everybody has a good day. Take care.